Alright, in this video we're going to take a look at evaluating limits involving complex fractions. So we've talked about simplifying complex fractions in the past, and we've multiplied every term in our complex fraction by the least common tiny denominator. So again, looking at all the tiny denominators that we see and finding the least common denominator of those tiny denominators. If we multiply every term in our complex fraction by the least common tiny denominator, then it will eliminate all those tiny fractions. So, example 2, we're going to start with the limit as x approaches -5 of 1 over x plus 1/5 all over x plus 5. Now, if we substitute or evaluate this limit, at x equals -5, we're going to get 0 in the numerator and 0 in the denominator, and we don't want that. So let's clear out these tiny fractions by finding the least common tiny denominator. And in this case, with the tiny denominator of x and this tiny denominator of 5, our least common tiny denominator is going to be 5x. So if we multiply every term in our complex fraction by 5x, we'll get rid of these tiny fractions, at least in the numerator. So when we do that, 5x times 1 over x is 5, 5x times 1/5 is x, and then rather than multiply or distribute the 5x to the x and the 5x to the 5, we're going to leave it in its factored form of 5x times x plus 5. And the reason we're going to do that is because in the numerator we have 5 plus x, and in the denominator we have x plus 5. Well, keep it in mind, it doesn't matter what order we add to terms, so 5 plus x is going to give us the same value as x plus 5. So we can actually divide those out or cancel them out and leave ones in their places. So we're going to have 1 over this 5x, and that's the reason why we didn't distribute the 5x to both terms. We're looking to cancel some common terms out. So now if we evaluate this limit at x equals -5, we'll get 1 over 5 times -5, which is -1/25. All right, part B, we have the limit as x approaches 3 of 1/3 minus 1 over x over 3 minus x. And this time our least common tiny denominator is going to be 3x. So when we distribute the 3x to the numerator, 1/3 times 3x is going to give us x, and 1 over x times 3x is going to give us 3. So in the numerator we'll have x minus 3, and in the denominator we'll leave it in factored form, 3x times 3 minus x. Now in the last slide, the expression in the numerator matched one of the expressions in the denominator. Here, we have the x minus 3 and we have a 3 minus x. So these are opposite expressions. And to see that, if we use a value of 7, 7 minus 3 over 3 minus 7, 7 minus 3 is 4, 3 minus 7 is a -4, so this would become 4 over -4, which is -1. And as a matter of fact, when we switch the order of subtraction, if you divide those two results, you'll always get -1. So these will cancel out, but instead of having a 1 in our numerator, we'll have a -1. So it simplifies to the limit as x approaches 3 of -1 over 3x, which then we can evaluate this limit directly. -1 over 3 times 3 is -1/9. Alright, that about does it for this video. In the next video, we'll take a look at limits involving radicals. So I'll see you then.